Hello friends, this is Professor Dattu Patel. Today's lecture we learn about divergence of a vector field. If u of xyz equal to u1 of I cap plus u2 of j cap plus u3 of k cap is a continuously differentiable vector point function in a domain D of space, then its divergence is denoted and defined as divergence of u div u equal to nebula dot u. Here nebula is a operator, that is I cap del by del x plus j cap del by del y plus k cap del by del z into u, that is our vector. Here we can also define u bar as well as u, both are correct, into u1 I cap plus u2 j cap plus u3 k cap. Then dot product of this, I dot I, that is 1, j dot j, that is also 1, k dot k 1, but I dot j 0, I dot k 0, j dot I 0, j dot k 0, k dot I, k dot j, that is also 0. Then we get del by del x u1 plus del by u2 del y del u3 by del z, which is a scalar quantity. That is a formula we use to finding the divergence in an example. Now, physical interpretation of divergence. The divergence of a vector field u at a given particular point may be regarded as a measure of how much field diverges or emanates from that point. Here, there are the few diagrams shown in the whiteboard. These all are the various types of divergence. First one is in first diagram, that indicates, this arrow indicates, and these all are the vector fields. First diagram indicate by the vector fields are spread out, matlab away from that particular point P. Then we can say that our divergence is a positive divergence, means vector field are spread out, means we can say that positive divergence, and that particular point we indicate by as a source point. If positive, it is positive divergence, then we can say that particular point is a source point. Second diagram indicate by the vector fields are towards the particular point P, then we can say that our divergence is negative divergence, and that particular point which is indicated by sink point, means if it is negative divergence, then we can say that given particular point, and this indicate by sinks point. And third diagram, the vector fields are parallel to each other, then we can say that it is zero divergence, means the vector fields neither positive divergence nor negative divergence, then we can say that it is zero divergence. Let us start with one simple example to finding the divergence. Example is Fy equal to x square z I cap plus minus 2y cube z square j cap plus xy square z k cap. Find divergence f bar at point 1, minus 1 and 1. First, f bar equal to f1, finding the divergence. Then formula of divergence of f bar equal to del dot f bar means I cap del by del x plus j cap del by del y plus k cap del by del z into f bar, that is x square z I cap minus 2y cube z square j cap plus xy square z k cap. Now dot product, then I into I 1, then we get del by del x square z plus del by del y minus 2y cube z square plus del by del z xz into y square. Now with respect to x derivative, then we get 2xz with respect to y, 3 2s are 6, y square z square with respect to z, then xy square, that is our divergence f bar. But we find at particular position which is given 1, minus 1 and 1. First value indicated by x, second value indicated by y, and third value indicated by z. Then substitute the value x, y, z in this equation and we get divergence f bar equal to twice x is a 1, z is also 1, minus 6 minus 1 whole square into 1 plus x is a 1 minus 1 whole square. Then we get 2 minus 6 plus 1. Then answer which is minus 3. Here we get divergence which is minus 3. That is negative value. Means that is indicated by negative divergence. Means it is a sink point. Another example. Find the divergence. Another example is f bar equal to x, y, z I cap plus 3x square y j cap plus z square minus y square z k cap at particular point 2 minus 1 and 1. In this example, here we find the divergence. Then divergence formula is nibla dot f bar. Nibla, that is our operator. Then I cap del by del x plus j cap del by del y plus k cap del by del z. Substitutes value of f bar, that is x y z I cap plus 3x square y j cap plus x z square minus y square z k cap. Then I dot I 1, j dot j 1, k dot k 1, I dot j, j dot I, k dot j, k dot I. These all are 0. Then here xyz, here 3x square y, here xz square minus y square z. That is our del y del z. Now differentiate with respect to x. Then we get yz. Differentiate with respect to y. Then we get 3x square. Differentiate with respect to z. Then 2xz minus y square. We find at particular point 2 minus 1 and 1. First value indicated by x, second value indicated by y, and third value indicated by z. Substitute this value in this equation, and we get y into z minus 1 into 1. Then minus 1 plus 3 2 square plus 2 into 2 into 1 minus 1. Then we get minus 1 2 square 4 4 3 is 12 2 2 is 4 in minus 1. The answer is 14. Means here divergence which is positive. If divergence is positive, then it is a source point. Now next one is solenoid of a vector field. A vector field is said to be solenoidal if divergence f bar equal to 0 at all the points of the function such that there is no loss or gain. If divergence f bar equal to 0, then the fluid is incompressible. If divergence not equal to 0, then fluid is compressible. Then above we solve two examples, which is positive divergence and negative divergence. Both has fluid are compressible. If we find divergence and we get 0, answer is 0. Its divergence f equal to 0. Then we can say that fluid is incompressible as well as solenoidal of a vector field. We understand these things as a counter example. Example is prove that f bar equal to 3y raised to 4 z square I cap plus 4x cube z square j cap plus 3x square y square k cap is a solenoidal. Then here question already prove that, then answer must be 0. Then we find divergence f bar that is nebula into dot f bar, here dot product. Then nebula, that is our operator, j cap del by del y plus k cap del by del z into f bar, then 3y raised to 4 z square I cap plus 4x cube z square j cap plus 3x square y square k cap. Then dot product is del by del x 3y raised to 4 z square plus del by del y 4x cube z square plus del by del z 3x square y square. Here with respect to x differentiation, these all the terms are constant and derivative is 0. Here with respect to y, then y was absent, then all the terms are constant, then 0. Here z was not present, then it is constant, then 0. Then we get divergence f bar equal to 0. Hence f bar is a solenoidal, as well as its fluid. Maybe in question we can say that fluid is compressible or not, whether it is checks a given function has a fluid as compressible or not. Let's we understand in a next counter example. Example is find constant B if given vector f bar equal to bx plus 4 y square z I cap plus x cube sin z minus 3y minus e raised to x plus 4 cos x square y into k cap is a solenoidal. Here find the constant B if f bar is a solenoidal. Question has condition already given, f bar vector is a solenoidal. Then here we writing the one statement, if f bar is a solenoidal, that is our solution. If f bar is a solenoidal, then divergence of f bar equal to 0. Then everyone visible it, f bar is a solenoidal, then divergence of f bar equal to 0. Then divergence f bar equal to del dot f bar equal to 0, means 0 equal to, that is our operator, then formula, that is formula of operator, then put the function minus e raised to x plus then 0 equal to del by del x bx plus 4y square z plus del by del y x cube sin z minus 3y plus del by del z minus, then minus the outside, then e raised to x plus 4 cos x square y. Now differentiate with respect to x, then b plus x was not present, then constant which is 0 with respect to y, then first term 0, minus 3, minus with respect to z, then 0 with respect to z, then 0. Then we get equation 0 equal to b minus 3, then b equal to 3, then value of constant b is 3. Here condition which is given in question, then we take divergence FR equal to 0. We must write this condition. Similarly, another example is prove that f bar equal to y square minus z square plus 3yz minus 2x I cap plus 3xz plus 2yx j cap plus 3xy minus 2xz plus z, here 2z, k cap is a solenoid. Here question which is given, prove that f bar is a solenoid, then answer must be 0. Another counter example is, if f bar equal to xz cube I cap minus 2xy j cap plus xz k cap, find divergence f bar at particular point 1 to 0. Another counter example is, if f bar equal to ax square y plus yz I cap plus xy square minus xz square j cap plus 2xyz minus 2x square y square k cap is a solenoid, then find constant A. This example you can try yourself as a tutorial as well as homework. If you have any doubts regarding this chapter, regarding above chapters, then feel free contact me. Thank you so much for listening this video.